Good morning, dear students. So today we will start the first module of basic thermodynamics. So here in the first module, so first all the fundamental things are there. So what is a system? What is a boundary? What are the surroundings? Then what are the properties? Types of properties. Then what is work? What are cycles? What are processes? Then what is the definition of thermal equilibrium? What is zeroth law? Then temperature scale, different types of thermometers, and first law of cyclic and non-cyclic processes. And the demonstration of the total energy, internal and enthalpy. So the definition of internal and enthalpy. So we will study in the first module. So first thing is to understand what is thermodynamics. So actually thermodynamics is an axiomatic branch of science which deals with the relation of heat, work and properties of systems which are under equilibrium condition. So this branch is axiomatic branch of science. Axiomatic means self-evidence. So this thermodynamic can be experienced. These are the true things. So this is called as self-evidence branch of science. So the applications of thermodynamics can be seen in the broad field of steam and nuclear power plant, which is used to generate electricity, then internal combustion engines, gas turbines, then in refrigeration and air conditioning, then in gas dynamics, jet propulsion, compressors, in many mechanical devices, then chemical process plants. So the applications is very broad. So here in your undergraduate course, so you will come to know many applications of this course thermodynamics. So basically there are two approaches in thermodynamics. So one will be the macroscopic or the classical thermodynamics. The second one is the microscopic or the statistical thermodynamics. So in macroscopic approach, the system is analyzed by taking the behavior of some average molecules. Suppose the property pressure. So here in macroscopic approach, the pressure will be defined as the average rate of change of momentum of all molecular collisions on a particular unit area. So that is the average pressure. So here in macroscopic approach, the pressure P is the average pressure of some molecules. The macroscopic assumptions are completely independent of the assumptions regarding the nature of matter. The macroscopic approach is also referred as classical thermodynamics. Then comes the microscopic approach or statistical thermodynamics. So in this approach, the matter is composed of myriads of molecules. If it is a gas, each molecule at a given instant has a certain position, velocity and energy. And for each molecule, these change vary frequently as a result of collisions. So the behavior of the gas is described by summing up the behavior of each molecule. So such a study is termed as microscopic or statistical thermodynamics. So here, so the behavior of each of the molecule is studied microscopically. So the examples where this microscopic approach is carried out is the study of the rarefied gases in rocket technology, in aircraft technology. So in all those areas, this microscopic approach is carried out. So whatever approach so we will be having in our basic thermodynamic course is macroscopic approach or classical thermodynamics. So concept of continuum. So concept of continuum generally comes under this classical and macroscopic thermodynamics. So when we will study under this approach, so we will follow this concept of continuum. Actually, it is a kind of idealization of continuous description of matter, where the properties of matter are considered as continuous function of space variable. So one of the factors considered important in determining the validity of continuum model is molecular density. It is the distance, this molecular density is defined as the distance between the molecules, which is characterized by mean free path. It is denoted by lambda. So in terms of concept of continuum, this mean free path is very much important. Another dimensionless parameter known as Knudsen number, so which is the ratio between the mean free path and the characteristic length of a system. So characteristic length is defined as the volume divided by the area. So lambda divided by capital L is the Knudsen number. So if the value exceeds 0.01 for a system, then the concept of continuum does not hold good. So this is the boundary condition for the concept of continuum to exist in a particular system. So you should remember these two terms, mean free path and the Knudsen number. Okay. Now, to have a study on a particular section or segment, so in relation to the thermodynamics, so first we should define what is a system. So system is basically one part of the universe which is surrounded by boundary, so where the analysis is done or where we will carry out our studies. So basically anything which is taken as observation and which is a part of space and which is having some mass is defined as the system. So here in this figure you can see one system, so which is separated by boundary. So here you can see a firm boundary and rest of the universe is called as a surrounding. So excluding the system from the universe is the surrounding, and this boundary separates the system and the surrounding. So here this point is written. So this boundary can be a real system boundary or it may be an imaginary boundary. So for some open system, so we will see some imaginary boundary. So if you divide the systems, so there are three basic types of system. So one is closed system, another is open system, and the third one is isolated system. The closed systems are called as closed mass system. The open systems are also called as control volume system. So in the next class, so we will be studying the definition with examples for these various types of systems. So dear students, if you are having any doubt, just you post it in Google Classroom. So I will be uploading this video shortly in the Google Classroom. And if you have any doubt, you can post it here, or when we will meet in the Google Meet, then also you can post your doubts. So we will clarify there. So thank you for listening.